Hello, prob stats, sorry about that, and welcome to 10.3. Today, we're going to talk about prediction intervals. So we're going to use our line of regression, and we're going to figure out where our value could actually fall so we can predict, like if at 13, where's my value of my height going to be? That's the type of thing we're going to look at. So make sure you have stat disk open and your notes, and let's go. All right, we're going to use a paired data sample. Let's see if we can get this up. There we go. To determine the value of the determination r squared, and then to interpret that value, we're going to use a given value of one variable t and predict the interval. So we're going to create an interval like a confidence interval, but this time an interval where our values are going to fall. Our prediction interval is a range of values or estimate of a variable, so where can it be? Unlike our confidence interval, which was a range of values to estimate a population of a parameter, so that was p, mu, and standard deviation, right? So this one's different. It's a prediction interval of a variable. All right, the requirements. We have to have a fixed value of x. The corresponding values of y are normally distributed about the regression line. And there's a normal distribution with the same variance is what we're going to be looking at. So now when we look at this, we're going to have our fixed and known value of x. They're going to create a prediction interval for y. So the y value is going to be y minus the error and y plus the error over our population. We actually have to do this formula this time. Stat disk will not do it for us. So our margin of error, r is t alpha sub 2, which we found before in our t value. Our estimation of error right here. We'll have 1 plus 1 over n. N is how many terms we have. And then our number minus our mean squared over our squares over our sum of squares. So S of E is our standard error of estimate, which is also found on stat disk. And I'm going to show you how to do that here in just a little bit. All right, we're going to do our chocolate and Nobel Prize winners again. So we've already created our regression line. We did that last time, which is negative 3.37 plus 2.49x. All right, for every 10 kilograms per capita. Now, I want to know, so x equals 10, and I want to know what values of y this could be. So where is this going to be? So if I substitute 10 in, I get 21.5. But I know it's probably not going to be 21.5. There has to be a range. So now we want to do a 95% prediction interval for our Nobel Prize winners. So how do we do that? These are the things we need. X sub 0 is 10. This is given to us. Our standard error is our correlation. So we go to correlation and regression, and it's right here. Standard error is 6.23708. Our y hat is what we found above, so that was from our equation. We're going to go to student distribution, so you're going to go to your analysis, your student t-value. You're going to have degrees of 21, all right? And when you type that in, of the 0.025, you're going to get 2.08. All right, that we've done before on stat disk. Nothing too major here. Descriptive statistics. So all of these are found on our descriptive statistics. Give me a second here. Let me get up stat. I was thinking I should probably show you how we found that t-value. So on stat disk, remember you go to analysis, probability distribution, and your student t distribution. Degrees of freedom was 21. And the value to the right was 0.025. Evaluate. Now when we look at here, this is where we got our 2.07. It was right here at this value at the very top. That's where that came from. Now our descriptive statistics, so we go to data, descriptive statistics, and we're looking at chocolate. Let me get rid of some of this here. Okay, now we got our values up. So we're looking at chocolate because that's our x value. So you're looking at the mean, which is on the top here at 5.8. All right, now if you go down to the bottom of our graph here, we got our confidence interval, and right above that, it shows you the sum, Well, that's the sum of x, so that's where the 133.5 came from on your notes. Then your sum of squares is under that, which is a 1011.45, also on your notes. So I hope you have found all of those things. So both of these came from our descriptive statistics. So we're not going to do this anymore since I've figured out how to use StatDisk a little better. So we found our mean, our sum, and our sum of squares. So this was called sum on our statistics, and this was called sum of squares, is where you were looking at when you found all your data. So now that we have all of our information, we're going to plug it into our formula on the other sheet. I just copied it over for us. So our t sub alpha of 2, alpha divided by 2 was 2.8. Our standard error was 6.24. 1 plus 1 over 23 plus 23. This is where we started with 10. Our mean was 5.84. Our sum, we took our sum of squares, which was 1011. Then we took the sum of x and we square it. You type that into your calculator and you get 13.41. Now this is our error. So what we do now is we're starting at the 21.5 because that's what we calculated at. So we take 21.5 minus the 13 and 21.5 plus the 13, which means our Nobel Prize winners could range anywhere from 8 to 35 basically. So that's an awful large range, probably because our data isn't very good. So when we look at this, we interpret it 95% prediction interval at 8.8 to 34.9. We select some country with a chocolate consumption rate of 10 capita, and we should have 7.8 to 35.3 Nobel Prize winners. It's a wide range. It's not a very good prediction estimator. If we got more data, that would help, or if our data was a little better, that would probably help. All right, I would like you to do the prediction interval for the right foot size of 13. So pause and do your work. All right, I hope you did good. A lot of this we've already done before, so we already calculated our equation on the other page. We already knew we're doing 13 because that was given in a problem. Our standard error when you typed it into StatDisk was 2.8. Y hat we found again on the other page was 78. And it was 0.025 because it was a 0.05 error is what we wanted our alpha to be. But I had 45 degrees of freedom because I only had 47 people. Yours could have been different. And I got 2.014. And this here, these three, were all found from our analysis. Not our analysis, our descriptive statistics. We typed it into E. So my error was 6.09. So now I have to take the 78 minus 68.09 and the 78 plus. So my final answer was my Y values between 71.91 inches tall and 84.09 inches tall, or 72 and 84. So not too bad. We did okay on our things. Explained and unexplained variation. Now this is when you're actually looking at your graph. My total variation goes from here to here. So this is the variation. Oh, I should explain where and why it came from. Okay, there's sufficient evidence to support linear correlation. Okay, this is my line. All right, the mean of all of my data values is 9 for the Y. So the mean of the Y value is 9. So this line is what we're comparing to right here, because that's Y equals 9. Now, when I look at the line here, let's say I'm looking at 5 and 19. So the difference between this and what the line says my value is right here, that's unexplained deviation. And then the difference between my mean and the line is explained deviation. So how much does my line tell me where my value should be is what we're looking at. So we're going to do this here also by math. So I'm going to substitute, this is my equation, I'm going to substitute in 5 and I get 13. Now when we look at this, my mean is 9. My point that I'm actually looking at was actually 519. So this was actual, and this is from my line. So now I'm going to take 19 minus the 9. This is 10, right? That's my total deviation. Now the part that's explained by my line would be 19 is where we're plugging in here. This is the point we're looking at. So the y-hat, when you plugged in the 5, I got 13. So it's 13 minus 9. So I got 4 that is explained. And then when we look at the 19 here, 19 minus the 13, so 6 is unexplained by my line. So the part above the line, unexplained, between the mean and the line is explained. So this is explained here and here, and this other part above the line is unexplained. Coefficient of determination, let's go here, is the proportion of the variation of y that is explained by the regression line. It's computed by r squared. It's explained over total. This here is actually given to us on StatDisk. All right, so when we have our 23 pairs of Noble data sets and we have an R coefficient of 0.8, the coefficient determination tells us the total variation in y that can be explained by the linear correlation. So if r is 0.8, r squared, we just square that, is 0.64. Okay, what this means is r squared is the proportion of the total variation that can be explained. So this is explained data. So 64% of the variation is explained by chocolate consumption. Right? That's what our line says. 36, so 100, so you're taking 1 minus the 0.64, which gives you the 36.36. So 36 of it cannot be explained. It doesn't make sense. So our line is okay. Not terrible, but not the best. All right, so I want you to calculate the coefficient and determination for the height and foot length data. So when you type this into StatDisk, let's pause it. All right, I actually forgot I was going to show you this in StatDisk, my fault. So I'm doing my chocolate and my Nobel Prize. So chocolate was my X, so it's in the first box. So we went to analysis, correlation and regression, 0.05. I'm going to compare chocolate to my Nobel Prize winners. Okay, when you evaluate, if you go way down on the bottom here, like the second, you got the coefficient of determination, which is your r squared, and we do not want the adjusted, we just want the r squared, and it's 64%. So this matched what we had above, but this is what we're looking at right here. You could have also taken the r from up here and squared it, but StatDisk does give this to you. All right, when you type this in with your data, you should have gotten my coefficient of determination was 0.67290, or my r squared. All right, that means 67% of our data can be explained by the foot size. Subtracting from 1, which means 33% has other factors. So like the height of your parents. Things on that order that do not have to do with your foot size, that determine how high you are. All right. Good luck with your homework. I hope you do well. Make sure you post questions if you have any.